Welcome to the session on conditional probability, conditional probabilities in Venn diagrams. The objectives for this session are to solve conditional probability problems using Venn diagrams and conditional probability formulae. Venn diagrams can help us find conditional probabilities if we examine the part of the Venn diagram which corresponds to the restricted sample space. Pause the video and have a go at this example. Press play when you're ready to view the solutions. Let's take a look at part A first. Suppose that two events A and B are such that probability of A equals 0.5 and probability of B equals 0.7. Given that A and B are independent, find probability of A intersect B. So let's solve this. Since A and B are independent, we have that the probability of A intersect B equals probability of A times probability of B, which equals 0.5 for probability A times 0.7 for probability B. And this equals 0.35. Now for part B. We are required to draw a Venn diagram given these probabilities, showing the probabilities for these events. So let's begin. Now we know that probability of A intersect B equals 0.35. So in our sample space, with the circles A and B as shown, we can place 0.35, the intersection of A and B, right in the center, like so. We also know that the probability of A equals 0.5, so we already have 0.35 in the A circle. Therefore, since probability of A equals 0.5, the remaining probability in this circle is going to equal 0.15. And similarly for B, the probability of B equals 0.7. Therefore, the other probability in this circle is going to be 0.35. And now let's consider the entire sampling space. All the probabilities added up should equal 1, and therefore 0.15 is also in this sample space but outside the regions for A and B. And now for part C, we are required to find probability of B given that A has already occurred. So let's solve this. Now from part B, we have this sample space with these probabilities. The formula for the probability of B given that A has already occurred is probability of B intersect A divided by probability of A. And this equals 0.35 divided by 0.5, which equals 0.7. And now for part D. We are required to find the probability of A given not B. So let's solve this. Again, from part B, we have our sample space with all the probabilities in it, as shown. And using our formula, probability of A given not B equals probability of A intersect B dash divided by the probability of B dash. And this equals 0.15 divided by, and the probability of B dash or not B is equal to 0.15 plus 0.15. And so we have that the probability of A given not B equals 0.5. Now let's take a look at part E. We are required to find the probability of B given A dash union B dash. So let's solve this. Again, let's use the diagram from part B. We are also going to use the formula for the probability of B given A dash union B dash. So this is going to equal probability of B intersect A dash union B dash divided by the probability of A dash union B dash. Here's A dash, so the complement of A, in other words not A. Here's B dash, in other words not B, or the complement of B. And the probability of B intersect A dash union B dash is only this 0.35 value, as you can see. And the probability of A dash union B dash is all these three highlighted probabilities added up together. And so calculating this gives us 0.35 divided by 0.65, which equals 0.538 to three significant figures. This brings us to the end of this session. If you have understood its contents, you should be able to solve conditional probability problems using Venn diagrams and conditional probability formulae. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.